Good morning, students. Dear students, today we are going to discuss on the part 5th of our video lecture for the chapter Newton's laws of motion. For the chapter Newton's laws of motion. So we are discussing for part 5th of our video lecture, and in this part 5th we had discussed about the numericals. We had discussed about the numericals on impulses. We had discussed about impulse in the previous video. In the previous video we had discussed about impulse, and about impulse we had discussed that it is the change in momentum. It is the change in momentum. Now, on the basis of that topic, on this topic, that is impulse, now today we will discuss certain numericals. We will discuss certain numericals which is based on impulse. So, students, let us start our discussion for a numerical in the front of you, and the numerical says that a batsman hits a ball straight in the direction of the bowler without changing its initial speed. So, if the initial speed it is given u is equal to 12 meter per second, and since the direction is changing, so we can suppose the ball is moving the ball is moving in this direction. So without initial speed changing, the ball comes in this direction. So v is equal to, we can take minus 12 meter per second. If the mass of the ball is also given. Mass of the ball is 0.15 kg. It is given to you, the mass of the ball is given to you, that is to 0.15 meter per second. So we have to calculate the momentum. We have final velocity. If we suppose this is the final velocity and this is the initial velocity. Now change in momentum, we have to calculate about the change in momentum. Change in momentum, and that change in momentum is mv minus mu, which is equal to mv minus u, and the value of v minus u 0.15 into 12 minus 12 kg meter per second, and it is equal to 0.15 into 24 kg meter per second. 24 kg meter per second, and its value, that is del P, that is equal to P2 minus P1, it is equal to 0.36 kg meter per second. It will be 3.60 kg meter per second. So impulse I is equal to P2 minus P1, and it is equal to 3.60 kg meter per kg meter per second, or you can say it as 36 Newton second. You can write it as 36 Newton second also. Clear, students? This is one of the question. Now we will discuss about the next numerical based on the impulse. So students, look at the next numerical which is in front of you, and in this numerical it is a little bit complicated numerical with respect to the previous one. And here you are seeing that consider a ball is falling from a height of 2 meter. Ball is falling from a height of 2 meter. Look at the diagram. From the height P, the ball is falling to Q. But the ball is falling to Q. So if we suppose that the initial velocity of the ball at P is equal to 0. Initial velocity at point P is equal to 0. Initial velocity at point P is equal to 0, and final velocity of the ball at Q. Final velocity of the velocity at Q, it is supposed as v, and it travels a distance of s is equal to 2 meter. It is given in the question. It travels a distance of s is equal to 2 meter. Then applying v square equal to u square plus 2as. V square, from this what can you calculate? You can calculate the value of the final velocity v, because initial velocity is 0, it is given. So v square is equal to 0 square plus twice of as, and as it is given as 2 meter, and the value of a, you can consider value of a as 9.8 into 2. So v square is equal to 2 to the 4 into 9.8, and it will be 4 into 39.2 meter per second. Since it is 2as meter square per second, and the value of v will be v is equal to under root 39.2 meter per second. The value of v is equal to, and it is equal to 6.26 meter per second. It is equal to 6.26 meter per second. So for this P to Q, we have calculated the value 6.26 meter per second. Now for the second half of the question, find the impulse and the average force for 2 meter. Now rebounding to a height of 0. Now by striking, it rebounds to a height of 0.5. And what is this? It rebounds for a height of 0.5 meter. Let u dash be the rebounding velocity. Rebounding u dash be the rebounding velocity. U dash we have selected rebounding velocity, and s dash is equal to 0.5. S dash is equal to 0.5 meter. Now again, final velocity at point R. Final velocity at point R is because after rebounding, when the ball reaches to this point, their velocity is equal to 0. Now again we have to calculate the initial velocity. We have to calculate here the initial velocity u dash. So again applying v dash square is equal to u dash square plus 2as. Since its acceleration is opposite, so we will take minus 8.5. Final velocity is 0 and it is equal to u dash square. You have to calculate, and minus 2 into 9.8 into 0.5 meter square per second, and from here u dash square is equal to u dash square, this will be cancelled, which is equal to 9.8 meter square per second square, and u dash under root 9.8 meter per second, and it is equal to 3.13. It is equal to 3.13 meter per second. So you have calculated the velocity of approaching this point and the velocity of rebounding this point. V and u dash you have calculated. Now impulse is equal to change in momentum. Again, you know that the impulse is equal to what? Impulse is equal to change in momentum. And change in momentum is what? Change in momentum is equal to mv minus mu dash. mv minus mu dash. And since minus mu dash, then it is equal to mv plus u dash. We have calculated the value of v, 6.26 and 3.1. 6.26, and mass it is given in the question. Mass is equal to 60 gram. 60 gram to calculate, it can be written 60 upon 1000 into velocity 6.26 plus 3.13 kg meter per second. And on calculating this 0.06 into 9.39, 0.06 into 9.39 kg meter per second, and its value is equal to 0.563 Newton second. Now, average force is equal to is equal to impulse upon time, because we write that impulse is equal to F average into delta T. So from here, impulse is equal to the average force, F average is equal to impulse upon delta. So impulse we have calculated 0.563 upon the time, that is equal to 0.2. Time is equal to and on division you will get 2.81. So on dividing it 2.81 Newton second and second. It will cancel out and it will be 2.817. So these are the two questions on impulse. Now we will discuss about the Newton's third law of motion. We will discuss about Newton's third law of motion. As you all have studied about Newton's third law of motion, students, Newton's third law of motion. Newton's third law of motion Newton's third law of motion tells that if there is action, suppose there is a ball. First I am writing that Newton's third law of Newton's third law of motion. Newton's third law of motion tells that I am saying that suppose there are two objects A and B. Two objects A and B. So if A is exerting force on B, that is FAB, then B also exerts a force on A, that is F. Suppose this is the board and this is our. If I press this board with a force, then board also give the same amount of force on our hand. If A is going to strike B with force FAB, then B also gives a force FBA, which is equal and opposite to FA. So it states that every action has equal and opposite reaction. Every action has equal and opposite reaction. Means to say that action and reaction are the two outcomes when two bodies interacts. Means when there is an interaction between two bodies, then there are two forces. One force is action and the other force is reaction. So action and reaction are the two forces. They always occur in pair. They always occur in pair. Look at here, students. If there is action, there is reaction. So there are two pair of forces. So it is said that they always occur in pairs. Some important implications about Newton's third law of motion. If I am saying that we can write this force FAB is equal to minus FBA, or you can say that if I am saying that net force, then FAB plus FBA is equal to 0. Means the net force or resultant force means under the action and reaction here the body is in equilibrium. Body is in equilibrium. Suppose I am taking an example. Suppose here is a table It is a tabletop, and on the tabletop, on the tabletop, book is kept on the tabletop. Book is kept on the tabletop, and if book is kept on the tabletop, then there is its weight mg and a normal reaction. So how this normal reaction takes place? Since the book is pulled by the earth by its weight mg, so in response, this is the action, this is the action, this is the action, and due to this action, a reaction is created by the table. Reaction is created by the table due to this action of the earth, and the resultant R minus mg is equal to 0, means the book is at rest on the table. Now, some implications of Newton's third law. Some implications of Newton's implications of Newton's Newton's third law. What are the implications? The first implication of the Newton's third law, that Newton's third law of motion is applicable. Newton's third law of motion is applicable irrespective of nature of forces. We need not to bother about the nature of the force, whatever the nature of the force, either it is mechanical force, electromagnetic force, electrostatic force, whatever the nature of the force, in all cases the Newton's third law is applicable. Second is action and reaction. Action and reaction always acts on two different bodies. If you are doing action on this body, the reaction is faced by your palm or your hand. So action and reaction always acts into different bodies. Third, force of action and reaction does not cancel each other. It is important point, beta. It does not cancel each other. Force of action and reaction does not cancel each other. When the forces are, if there is a point, two like forces are acting on the same body. If two like forces are acting on the same body, then these two forces F1, if F1 is equal to F2, then F1 cancels F2, if they are acting on the same body. But if for Newton's third law, here there is body A and there body B. The body A is giving a force to body B, and body B is giving to the force. This is body A and this is body B. This is FAB and this is F. So these two forces are acting on two different bodies. So they are not going to cancel each. Since the forces are of similar nature, same equal forces, but they are not going to cancel each other. And the last point, if there is no action here, F1 cancels F1 cancels, and the last point, I'm writing here the last point, the small point easily. Fourth point, there is no action, then there is no reaction. Means action and reaction occurs simultaneously. If there is no action, then there is no reaction. Means action reaction are always paired forces. Action and reactions are always paired forces. They act in pairs. So that's all for today, students. That's all for today. And in the next video, we will discuss certain questions based on Newton's third law, and then we will start. So till part 5, we had recapitulated whatever you had studied, and in your syllabus, it is supposed that the deleted portion. Now we will discuss for the conservation of momentum in the next video. So that's all for today, students. Thank you. Take care. Have a nice day.